Hello everyone, I'm Kelvin from LightSpeed Studios, and welcome to my talk on practicing a procedural pipeline for dozens of games. Before we start, please allow me to introduce you to LightSpeed Studios. We are a leading global game developer with teams across China, the United States, Singapore, Canada, the United Kingdom, Japan, South Korea, and New Zealand. I know it's lots of countries. And our team, LightSpeed Art Department, is composed of dedicated artists who focus on researching the latest trends and cutting-edge technologies to support all of our games, and support them to improve the quality of art design, covering a wide range from FPS to MOBA, from photorealistic to anime. I would also like to mention that I have been presented in GDC and GTC in the past several years. If you are interested in learning more beyond the contents of this presentation today, or if you are curious about how our solution have been evolved to where we are today, you are welcome to search all these subjects online to have their records. So, as I mentioned, we are a giant game developer that can run dozens of games simultaneously. You would understand that it is impossible for us to provide a turnkey pipeline for all of them. In fact, we support most of our projects by sending our technical artists to help them to build their own pipeline. And when the next project comes, the technical artists switch and build it over again. This does not sound like a sustainable solution, right? Because although these projects are so different, but we can still try to extract some commonalities and reduce the overall cost for the whole studios. This is what I call the foundation of versatility and why I'm here today, showing you our latest practice about being supportive for dozens of game projects. And our secret is to break solutions into middlewares. This idea first came to my mind last year when I first saw Project Pegasus. And I think some of you guys maybe have heard that, which is a SideFX in-house tech demo designed to use Houdini's procedural workflow. There was a tutorial inside this project that introduced Houdini's public API and demonstrated how to use it in Unreal Blueprint. This is really inspirational for me, because before this one, the only well-known solution of using Houdini in Unreal Engine is Houdini Engine, right? However, the Houdini Engine is not really programmable. I know Houdini Engine is an open-source project, but no one wants to change its source code whenever there is a new in-house requirement. Ideally, the technical artists should be able to program Houdini in the game engines using scripts or nodes, like what they always do in Houdini itself. And you know what? I think Unreal Engine was born for this. With its amazing blueprint framework and reflection system, users can do whatever they want without writing a single line of code. For instance, when you want to invoke Houdini in an Unreal actor, instead of using a hard-coded Houdini asset actor, you can choose a random actor and integrate Houdini's power by adding several blueprint nodes inside. This way, users can literally access Houdini everywhere in Unreal. As I'm showing here in this slide, we use it in Blueprint Actor, in the Editor Utility Widget, in the Scriptable Tools, and everywhere. This is what I call breaking turnkey solutions into middleware, and in the Project Pegasus, the middleware means Houdini Public API. And if you want to learn more about Project Pegasus, you can just refer to this link here. So I've made some demo videos for this. The first video is about Scriptable Tools, the same as they used in Project Pegasus. The algorithm running in the background here is SOP sweep. Therefore, the generation result is quite simple. But you can feel this smooth user experience here that Houdini responds to the modification of the spline immediately. And all the logic, including those little gizmos in the viewport, are managed by a blueprint graph. So from an HDA to a tool like this, not a single line of C++ or Python. And the next one is about Blueprint Actor. The HDA I'm using here is from SideFX Labs. As you can see, after I changed the bounding box, I could press a button and make Houdini generate a building for me. I can interactively edit this bounding box because I attached a brush component underneath my actor. I attach this actor because it is an Unreal built-in feature that allows users to edit the geometry brush in the viewport interactively. So there is no need for us to develop a built-in controller ourselves. Once again, I think it shows the magic of mixing Unreal and Houdini using Blueprint. And this one I think is even more crazier. Like, think about you have tons of assets, and you want to process them all together. Like what I'm showing here in the video, I selected many geometries, and I want to crush them all in one shot. The Editor Utility Widget is really helpful in this case. By making a for loop in the Blueprint graph, the Editor Utility Widget can become a bash tool. Here, I'm using the Voronoi fracture for better visual effects, but actually in the production, we primarily use this solution to bash generating level of details. Yeah, so I didn't really show the Editor Utility Widget blueprint graph here, but I can just promise everything here, including this Editor Utility Widget, is just blueprint based. So the Houdini public API is good enough to implement all the above tools. But in LightSpeed Studios, we want something even more flexible and universal. As what I wrote in the subject, our final decision is to use OpenUSD. But the question is why? To answer this question, we have to figure out what is procedural. Or how can we make the pipeline be procedural? In my opinion, a procedural pipeline always includes the following 3 steps. First, we have to send the assets from a host to a server. The host and server can be variant. Here, when I'm talking about assets, I mean everything in your digital world, including terrain, foliage, building, character animation, material, etc. And then in the second step, we let the host send commands to the solver, like running a Houdini HDA or maybe rendering a substance shader. And eventually in the third step, we send the generated result back to the host. This way, we complete a procedural cycle. In other words, any system that can automate these 3 steps can be called as a procedural system. Now it's time to talk about our choice. We describe the whole digital world in an OpenUSD file and utilize JSON to describe the task info. We chose OpenUSD not only because it can describe almost everything in a 3D digital world, but also because it's a great community. All software listed on the screen supports OpenUSD natively, and more of them didn't show up here. It saves us lots of time since we don't have to develop from scratch for each software we use. The data format has been determined. Now we should figure out how we can transport this data. The most straightforward idea is to use the file transfer protocol. We can save USD as a file, import and export it as we always do to the other file formats. However, we have collaborated with NVIDIA since 2021, which is exploring the possibilities of using Omniverse in game production. Long story short, the most valuable part of this collaboration is the incremental data update. You can think of it as an optional performance optimization that allows you to transmit only the delta instead of always the whole USD file. I won't delve into more details of Omniverse today. If you are interested in it, please refer to another presentation this year earlier in GTC with the link here. So I think the goal of our pipeline is to break the boundaries in between any 2 different software. Through OpenUSD, we open up the possibility for Unreal to interact with a wide range of DCCs. By putting all DCCs in the cloud, we make them services. Our artists are not confined to only Houdini. They can use whatever software they want to use. And artists also can use OpenUSD to share their digital scenes and also the generated results, which is a great help for teamwork. Now you have a brief understanding of our work. Let's move to the third part today, which is the USD schemas for games. As an open-source project from Pixar, USD was initially built for films and animations. It misses certain features and functionalities for games. or in USD terminology, it means game schemas. For instance, we cannot describe foliage or landscape in USD, I mean natively. But we have to use them, right? We cannot accept that a universal format can only support geometry as materials. And the good news is that OpenUSD allows us to extend its features ourselves. This slide describes the USD standard we are using in LightSpeed Studios. We have our in-house implementation for things like foliage, landscape, collider, decal, and all the other things. We also added some support for some Unreal-specific structures like a data layer, the table, and the blueprint. And here is worth mentioning, I want to also give you an example here, is that we support simple colliders, like spheres, boxes, capsules, etc. As a comparison, almost all the rest of the file formats support only convex, which means that if you have some like metables in Houdini SOP, which are essentially described by some central points and a radius, and you want to transport them into Unreal as colliders, with OpenUSD, you are able to have exactly the same sphere colliders in Unreal, but I think in all the other solutions, your metables will be converted into convex. There are many more examples like this, such as decal, data table, and blueprint, etc. To be honest, there are still a lot of data types of Unreal Engine that we don't support yet. But we want to support them as much as possible. And by the way, we are in close contact with Epic's US development team, and we are collaborating with them to improve support for game workflows inside USD import and export features. I also provide some videos to demonstrate a part of this special data type. The first one is about decals. As you can see, by using Houdini's font node, which is a simple node everyone uses, right, the hello world, I can paint these letters on the landscape. Since the generated results are essentially decals, so I can modify their fit screen size, which is a parameter of decals, by changing the HDS parameter. And this is why we have to develop like some USD schemas for games. Like I mentioned, like if you use Houdini engine or some other procedural solutions for structures and data types like this, like decals, it's really hard to do procedurally. But with USD, it kind of opens up the possibilities for us. The next one is about generating volume textures. I believe everybody here knows how to export a VDB file from Houdini and import it to Unreal as a volume texture. However, that workflow includes lots of manual work. You have to drag and drop your VDB file into the content browser, assign it to a material, and more, right? Luckily, USD supports VDB natively. This means that we can set up a material graph inside USD using VDB as the parameter. This way, we can proceduralize the whole process and make a tool like this one. Like you can see, all the properties here are properties of HDA. But using that HDA, we can not only generate a volume, but can also control a material like the color, like what I'm showing here in the video. When I'm changing the volume color, it responds immediately. And the last one is quite interesting. I don't know if you guys still remember the building demo I showed at the beginning of the presentation today. Once we compile a Houdini actor, it will become an Unreal asset. This means that if we have the power to generate blueprint assets, we can generate this Houdini building actor we just made. So here in this tech demo, I used the lob subdivisions HDA to instantiate some Houdini building actors to the scene. And after that, each generated actor can cook itself. We can even do it recursively. Like we can first generate a city, and the city, they are all Houdini building actors, and inside each Houdini building actors, it can like contain a series of Houdini instances that can generate window doors if it's necessary. So yeah, here we are at the last part of my section today. I'll delve into more details of our blueprint graphs and show you how the above tech demos have been made. If you want to cook HDA in Unreal, you must be able to change its parameters in Houdini. Since we don't use Houdini engine like in our pipeline because we use the USD pipeline, it seems like we have to re-implement all these things ourselves. But the fact is, we don't really have to. The only program we wrote here is a script that can translate an HDA into a Python file. And this Python file follows the Unreal Engine's grammar. So it can be loaded into Unreal and generate the detail panel for us automatically. And this is about wiring up HDAs. Yes, we support our artists connecting multiple HDAs in Blueprint as if they are using Houdini. Earlier today in this talk, I mentioned that we use JSON to command Houdini. This means all these orange Blueprint nodes here and in this screen are actually modifying a JSON string in the background. This is a very simple and effective solution. After reading this JSON string, Houdini will understand that how many HDAs it should cook and how they connect with each other. It also records the information on what USD file it should read and what USD file it should write out. Although that almost all DCCs support OpenUSD natively, Houdini is one of the best. With the powerful Solaris system and LOB network, we can seamlessly translate data between SOP and USD. This screenshot is the typical use case in our pipeline. After reading the USD files, we pre-process the data using several configuration nodes, such as the one pre-processing thing we have to do is that translate Unreal height maps into Houdini height fields, and more of that, right? Then we invoke the actual HDA via a SOP modify node, and end up with a series of post-processing nodes and read it back to USD files. I think the beauty of Solaris is that it is not just a bridge for SOP, but also an excellent editor for OpenUSD. So far, all the elements of cooking an HDA are in place. The only thing we need to do now is that to automate it. We implement this by using the event graph of Blueprint. The event graph is a Blueprint built-in feature. And in this slide, I listed several common events that we always use. Like when the HDA's parameters change, we may use this event to send the new properties to Houdini, and we may upload a new USD file and request Houdini to cook over again. And when detect the USD file is loaded, we may refresh the Unreal editor and notify other procedural tools downstream. And when Houdini sends an error or success message to to Unreal, we can listen to this event and promote a message to users. These are all for the subject in my talk today, which is to support different artists and support different game projects to build their own procedural toolsets. Seeing all this, you may ask if I should always have to create a new Blueprint assets to integrate a new HDA. Isn't it too much work? We anticipated this issue and solved it by using a predefined Blueprint template. So in this tech demo, you can see that users can drag and drop the generated Python script into the viewport. And our plugin will instantiate an actor automatically based on that Blueprint template. This way, we can provide a Houdini engine-like user experience. And the only difference here is that we use the Blueprint actor, which allows the users to customize it afterwards. And thank you all for watching. At the end of this presentation, I would like also to close with another tech demo, but this one is much more prettier. Our artists have developed a project to test this Blueprint and OpenUSD workflow over the past month. And we call it LightCraft. Now let's have a look. So inside this tech demo, you can see that Scriptable Tools, Editor Utility Widget, and the Blueprint actors all work together. You can see here, this panel is Editor Utility Widget, Scriptable Tools, and all the generated results are essentially Blueprint actor. You can see the types there. And this demo is not only using Houdini, it's also using a tool that from Procedural Lab that we buy it. And can show like you can use Houdini to generate roads, trees, but use Unreal's built-in plugins and features to generate buildings like this. So it's kind of Houdini and Unreal collaborating with each other. Yeah. I want to give special thanks to my colleagues like Eve, Lloyd, Lorenzen, Yunlong, Maurice, Joshua, and Paul, and many others across Epic Games, NVIDIA, and also SideFX. Thank you for all your support so we can work out this solution together. Thank you.